Thanks, Simon. We now have the responses to our final question for the audience, which was, how would you describe your use of high-performance computing? 23.6% said workstation, 1.8 said SMP, 38.1 cluster, 7.2 supercomputer, 10.9 grid, and finally 18.1% of you indicated that you do not use high-performance computing. So does our panel have comments about these results? Simon?
I think that it's absolutely the case that use of clusters is that real peak, and certainly that bears out the statistics and the data that Earl went through. What is very interesting to me in terms of actual use of high-performance computing as perceived by the audience is some real usage of grid in terms of the way in which they access and use high-performance computing facilities. Back to Tony and Earl.
Earl, do you want to go first?
Sure. The interesting part to me is we have 18% that are not currently using high-performance computing. One study that we're just launching in the next month is a study of what we're referring to the never used. In other words, it's scientists and engineers who may be having computationally potential problems but have not yet stepped up to doing technical computing. And we're doing that on behalf of the Council on Competitiveness to see how you can improve the competitiveness of industrial organizations by incorporating more use of technical computing. So it's very exciting to me to hear that 18% are in that category.
Yeah, I would pick out, you know, 24% workstation and 18% not using. It's interesting that that's 40% of the audience are at least thinking about using HPC, and I think it is now plausible that it's going to be a commodity technology that people can use relatively easily, as opposed to a sort of sport for academics to go and test their wares. I think it's now becoming a commodity.
Okay, thanks again. This concludes our formal presentation, and now I'd like to turn it over to our audience to ask any questions you may have for our panelists. Okay, our first question asks, how would you describe the difference and pros and cons between clusters versus blade servers versus grids for linear and nonlinear FEA solvers? Would you all like to hear that again?
That's okay, yes, I think I've got that.
Okay.
Comments on that. It's certainly the case for those sorts of finite element solvers that an important aspect in any of these engineering problems is setting up the geometry, and we certainly have a trade-off in terms of our calculations between that construction of the geometry and perhaps the generation of the mesh associated with it, where we might use a conventional high-performance computing machine where we need access to a large amount of memory and processing power in order to just be able to configure that CAD geometry in order to be able to mesh it. But then later on, as we go through the solving process, we find the scalability of clusters of not necessarily particularly tightly coupled machines quite acceptable for doing the calculations and the solving of those finite element problems. Blade servers are one of the mainstays of the key resources that we use in the university. Grids are kind of okay where you need to be able to spread out your calculations amongst a large amount of resource, so long as the individual resources on the grid can do that solving process. But I think that underlying all of this for us is the drive to do optimization, where the ability to be able to span out that calculation many, many ways and then bring back the results. That, if you like, is one of the challenges of technology in terms of bringing together all of these different things to use them in the example that you cite.
So, I mean, this is not I'm not an expert in this area, but I have worked with people using finite element codes, and the sort of distributed computing that grids epitomize is not, I think, where I would have thought that was primarily the use. If you have a supercomputer or a closely coupled cluster, that's where you would use for your finite element calculation. And as to clusters and blades, that's sort of a difference in packaging, so I'd sort of like to know what Earl thinks on that.
Sure, and I agree with you. I think with grids, there are some latency and bandwidth issues that tend to move this particular set of applications away from grids and are more close, somewhat more tightly coupled. And so the clusters and blades, what we're seeing right now in technical computing is blade adoption has been relatively slower than expected. They were more adopted in commercial installations. Part of the issue with the blades is historically blade technology lagged behind cluster technology somewhat. Sometimes the processors were a few months out of sync, shall we say, as far as the most current one. In addition, there was a premium to be paid for blade technology when you're putting together larger systems. In the last 6 months, we've seen the difference in technology time windows and the price premiums go almost to zero. So what we're watching very closely right now, and we're seeing in our last survey that we did a few months ago, about a 40% interest in blades, which is about twice what we saw a year ago. So we do see an uptick in that.
But are blades just a different way of packaging the processes in the cluster?
Right. Generally, a blade is, we view it as a daughter card that may have actually a disk drive in it and different components. So it is a slightly different way of packaging it. It is much more convenient when you think of a big rack where you can just slide in a blade with its own disk drive. But part of the issue is matching your problem, how much storage and where you want the storage. It can be a tremendous advantage. And in commercial processing in particular, it's a very large advantage having that extra storage on each board.
Okay. Our next question asks, how much cluster grid uptake do you see in the industrial life sciences, protein modeling, simulation, virtual high-throughput screening, docking, etc.? How much cluster grid uptake do you see in the industrial life sciences?
Okay, well, certainly I've interacted with Novartis, who have been pioneering various forms of grid for doing protein docking calculations. And so they've been doing largely idle cycle stealing, but certainly they believe that's cost effective and is transforming the way that they do their search for potential drug candidates. I don't know, Simon, do you want to come in on some other applications?
So it's certainly the case that there has been a considerable take-up, and really in terms of that use of grid in the biosciences, there it's often been driven by the desire to do optimization, to do tuning, to understand a profile of activities that are happening in some particular biomolecular simulation. It was very interesting, just going back to the audience poll, that, as I said at the time, that almost standing start from cluster to grid or high-performance computing in life sciences, that it's pretty much caught up with the way in which that technology has penetrated engineering. And so the sorts of companies that people around here work with, the GlaxoSmithKlines, and there are companies like Acceleris, there is considerable take-up. And I think that we stand by coupling high-performance computing with databases to be able to change and increase the way in which we can model and understand these sorts of biomolecular simulation, biomolecular systems.
This has been a very interesting area for us because we've added the study of application software and middleware over the last 2 years. And of all the industrial segments, the bio-life science is very unique in with its application profile, its purchases and that. It's actually halfway between an academic or university type customer and a more traditional industrial customer. And so, for example, cluster and grid uptake has been very strong in the bio-life sciences, but so has the movement from workstations to smaller platforms, and also the use of Windows as an operating system is much stronger in the bio-life sciences than the more traditional technical computing sectors.
Okay. Our next question asks, what will be the next wave of innovation in HPC? What will be the next wave of innovation in HPC?
Well, I think we are in the midst of one at the moment with clusters and grids. Clusters, I think, are mature. I think grids are not yet mature, which will become mature. But I think then the topic that I ended my talk with is really there is going to be a multi-core future, and I think that will lead to a new set of challenges, and undoubtedly there will be innovation and companies with particular advantages and products. making use of these multi-core chips. So that's what I would say. After grid becomes mature, which it's not, I think you'll see multi-core on the rise, and how we adopt multi-core in commercial and academic scenarios. So that would be where I would place my bet.
I agree completely with you. I think the next big wave that's coming along is based on your chart. I think you had the quote that hundreds of cores on a socket by 2015. I think the whole issue of dealing with much higher levels of parallelism at different levels and different hierarchies. And I think particularly when each core hits 16 is kind of a magic number we're looking at, because that's a large SMP in a socket. And the ability to change your science, your applications, and how you're using the computer, I think will be more the judge of your success in HPC than what kind of hardware platform you're acquiring. So it becomes much more software and parallelization capability, but also dealing with mixed types of cores, which I think will be a very interesting level of complexity. And so to me, the big solution, or the next big wave, is making all of it invisible. Is what can be done to take grid software, all the research in grids, all the applications in grids, and really make these multi-core processors successful.
Now we're looking, I mean, with Simon, at potentially using things like the Xbox, which is, if you like, it's not on a chip at the moment, but it's different types of cores. It has graphical processors as well as conventional processors. Could you use that in a more general context? So I'm sure Simon has some application context.
So that's absolutely the case, Tony. And just to add in that kind of aspect from left field, these waves of innovation that we've seen have very often been driven by cheap commodity technologies. The clusters that we build out of, the processors that we have been driven by gaming technology. So it's right for us in the sort of lab in which we work, and the sort of environment in which a number of people in the community are working, are thinking about what other generations of commodity technology there are. And you're absolutely right, Tony, to identify those sorts of graphical processing chips, or the sorts of processors that you see in games consoles like, you know, Xboxes.
Okay, we have another question. This one is for Simon. What value can Windows CCS deliver to engineers that Linux-based HPC clusters don't currently deliver?
So, I mean, we use a whole range of different platforms, and have done for the best part of 10, 20 or so years. And for us, in terms of that deployment of the Windows technology in a variety of different sectors, it's absolutely been quite straightforward to integrate that into the infrastructure that we have, to leverage, you know, the underlying Active Directory, and to leverage the expertise that our organization has in Windows in managing multiple thousands of users. So there's that side in terms of integrating and actually just kind of rolling it out. When we've launched Linux-based systems in the university in the past, you're always kind of adding in something that's perhaps slightly different from the expertise of the administrators. But when we kind of pitched up with this idea to install a Windows-based machine, they said, oh, so that just looks like some more desktops, that just looks like stuff that we're familiar with. So I think that's one dimension in terms of actually rolling it out. I think the other side that we ought to, that we've certainly found, are some of those productivity tools, things like the Visual Studio type design environment, but also the ability that we've found in terms of deploying Windows machines, of just being able to interoperate and being able to actually interact between different systems. And so that I hope gives you a feel for some of our early experiences with the Windows cluster compute technology.
I mean,